Hey, oh yeah, how you doing?
Hi, I'm pretty good, thank you. How are you?
That's
Thank you for having me.
great. Thank you. Thank you for doing the presentation. We're right on time for you to start. So if you want to go ahead and share your screen, we can get that going.
Sounds good. Yeah, I was trying to figure out how to share just the deck.
Yeah, if you down, it says share, and then you can just select the window once you have
All right,
if you
let's
already have
see.
the PowerPoint up.
Share screen, and then yeah, I have it up.
Perfect.
See that actually. All right.
Perfect. Go ahead and start the presentation in full screen. I see it.
Yeah, I think that's gonna happen now.
Yep. Give it a second.
No.
Oh, I see. It's the wrong
All right,
screen share.
wrong screen. Yeah, I see. Yeah,
What
let me
the
go back.
joy of doing these things
Yeah.
live. So yeah, but
All right.
anyway, so if go ahead and get that going, Alia. All of you people watching, remember, ask your questions using the hashtag .NETConf. We have a team of people looking at them and putting into the tag board. So keep them coming, and thank you for if you've been watching the entire day, like some of you have, I know. Thank you so much. Remember, all of these are going to be recorded and posted on YouTube channel 9 after the conference. It usually takes us a couple days to get it all spliced up because we'll remove some of the banter, like me talking right now, so you don't see any of that. You just see the great content from our speakers. So also we have on the website, remember, we have a swag bag giveaway. So I recommend that you go to focus.netconf.net. Thank you so much. There and /swag, and then sign up and get that going. So that would be great if you can do that. We're planning on giving away the prizes here at the end of the day. So if you want to be part of that group, please go ahead and sign up. So still trying to figure it out?
Yeah. I'm sorry.
It's
This
all
is
good.
taking a little bit.
Yep.
Yeah, I guess I'll just share a different screen, whatever one is there.
Yeah,
Yeah,
I recommend whatever. Go ahead and start your PowerPoint and get
yeah.
it all going, and then do share in whatever screen that's in full screen. Share that screen.
Sounds good. Okay, I'll try and do that.
Yeah. So the funny thing about, and go ahead, keep doing this. The funny thing about this, I literally am getting a tan because I have a screen here, I have another screen here, all over the place because we
Yeah, I
need
just
that much
listed all my
stuff.
screens. Yeah.
Yeah.
All right,
It's
let's see
always
if
great.
it works this time. Yeah,
Yeah.
sorry for the delay. Let's see. This should be the one, I believe.
All right.
Yeah, that looks better.
There it is. I'll bring it and I'll mute myself and go take it right away.
All right, thank you. Okay, so hi everyone, and welcome to my session, and I hope you will enjoy it. So my name is Ola. I'm a software engineer, and I have joined my current company, Dimitrix, almost 2 years ago, and that brought me into two exciting spaces. So one is I made a dive into biotech. This is a domain that's nothing like I've ever had to deal with before. And another thing is getting to code in F# as a full stack programming language, which is something I was sort of prepared for, but I was really excited to do it. And so this has been a really fascinating journey for me. And I would like to share it with you, and mainly focusing on the software part of it, and of course focusing on F#'s role in all of this, and it being the main tool for building our software. So before I get started with it, I would like to say thanks to all of the software engineers at Dimitrix, all of our people who do data science, IT, all of our scientists, and also a huge thank you to F# community, because it has been incredibly helpful over time. And without all of these people, the things that I'm going to be talking about here wouldn't really be possible. So a tiny bit about me. So I'm a software engineer. The first and like the most part of my career, I was a classical .NET developer, mainly coding in C# and doing some F# in my spare time. And since recently, I have been a full stack F# dev and have been enjoying it. And here you can see some of my interests in tech, and here's my contact info. So as for the plan for the talk, first we'll take a quick look at biotech and how cool it is. Then I'll tell you about Dimitrex and what we do, challenges we face. We'll take a look at our zoo of technologies, the software we built, and then the role F# plays there, problem solutions, lessons learned, and hopefully we'll get to Q&A as well. So the biotech world. So when you start looking at it, exploring it, it kind of makes you feel like you're in some kind of a science fiction novel. There are so many things that are possible currently, and this sphere really keeps developing really fast nowadays. And for example, a cool project in the medical domain is malaria medicine manufactured with yeast. There are a bunch of interesting things going on in the environmental space. So scientists figured out how to biosynthesize various construction materials like cement, or biosynthesize things like leather. Also, there's a cool project in the food space, impossible foods. So what they did, they discovered that heme molecule is basically the molecule that's responsible for a lot of the meat's properties. And so using it, you can sort of replicate the meat. And so they, just like Amyris for the medicine, they modified yeast genetically to make it produce that heme molecule and set up a process to produce impossible meats or impossible burgers with those meats. There are some weirder use cases, like people are trying to use DNA as a data storage and store data in DNA, like catalog DNA. And there are some fun products like Biotech, which is a biosynthesized probiotic that eats acetaldehyde, which is something that causes hangover. And so before I just talk too much about it, let's actually move on to Dimitrex and what does it do in the biotech space. So as for Dimitrex, similarly to some of the examples that I talked about, we're in the space of metabolic engineering, and we genetically modify yeast and kind of put the metabolism of a plant into yeast, and using fermentation, make it produce the compounds that we need, just like the plant would do. And so the current focus of Dimitrex is on synthesis of rare cannabinoids that are safe, legal, useful, and good for health and wellness. And you would think, why would you do it instead of just extracting those from the plant? So the thing is, especially for the rare cannabinoids, it wouldn't be really efficient because you would have to waste a lot of plant material to do that. And yeast itself, it's easy to grow, and therefore, based on yeast, you can build a nice and scalable platform. And you just have more control over things like making your process cleaner, more efficient, which is pretty great. And that might sound a bit easy, though I'm telling it, and you might think, oh, I can just set up a lab at home and just do the same thing as Dimitrex does, but not really. There is devil is in the details, and you will see it soon enough as I'll be showing you how the process looks like and how the software that supports it looks like. So at the kind of very high level view, there are two main avenues that are necessary for things to work. So one is the R&D and strain engineering, which is basically focused on designing optimal yeast strains and all the things around it. And the other one is manufacturing and process engineering, which is focused on all things related to and around the fermentation. And this is all not easy because you can't really just make a perfect strain of yeast from the first attempt. You have to make a lot of experiments, do a lot of testing, analysis, and you need to optimize things too. And then fermentation is also not that easy because you need to figure out how to make it consistent, how to make it scalable and robust, and how to make the strains perform optimally, ensure that they don't die or anything. And also you need to extract and purify and preserve your resulting products. And for all of those things, you need processes set up in your lab. And for each process, you need a team to run it and enhance it and maintain it. Let's see. And this is bits of what it looks like in real world in the lab. So you see some of the robots here and some of the lab setup, and it's only a small part of what's actually there. And so as you imagine, those robots produce a lot of data that you need to work with and make sense of. And for all of the experiments, you need to capture all the relevant information. And you also need to orchestrate between the different groups in terms of timing of things to happen, given all the dependencies that are there, and keeping the possible issues in mind, like something breaking or going wrong. And of course, given all of that, for a lab to be efficient, you need some good software to support and make this process optimal. And you probably won't be able to just get away with spreadsheets. Well, I mean, you can, but you won't really be efficient or scalable. So if we look at the logical view of it, this is actually a view that was generated by my coworker Heen when she was doing user story mapping sessions with all of the scientists. So here, only some of the parts are shown, and you can see the complexity. And if you further zoom in, some of those little squares would also become complicated workflows. And so we actually need to build a model of all of this, of the real world. And we need to make sure that we don't make it too complicated, because then you'll just drown in complexity and won't be efficient. And if you go too abstract, you'll just lose some valuable data and insights. And you need to care about things like the software being extensible, scalable, et cetera, and of course have a nice user interface for the scientists to be happy. So that leads to some of the challenges that we face. So there are some challenges that are specific to our world listed here, and there are also the challenges that are pretty much common for any software developer out there, like hosting your application, testing it, setting up CI, logging stuff, choosing a good source of, choosing a good place to store data. And so all of this combined is a lot to deal with, and like we'll take anything that will help us to save us some headaches. And the thing that will help a lot is the right choice of technology, because that can really make a lot of things easier. And so let's actually look at our technical landscape and what's there. So as you see that at the very heart of it, we have full stack F#. So we have Giraffe as the web server sitting on top of ASP.NET Core. We have Fable Elmish for the front-end stuff. And the rest is pretty standard. Like we host things on AWS and we use PostgreSQL as our database. And if we look at our applications, we have three main ones. The core one is LIMS, which is Lab Information Management System. And then we have a commercial app that's in the works. And then we have a data warehouse with an app for visualizing some things, and Grafana that is hooked up to the warehouse. And besides that, we also have smaller apps and scripts developed by software engineers, scientists. Not all of them are written in F#. Some of them are in Python and R. Excuse me. And they also need to talk to LIMS. And so in order to achieve that, F# has been really helpful. And I mean, having F# as a language that is everywhere, because then you can share a lot of the code across your front end and back end. And that includes some of your types. That includes code that helps you deal with the control your code flow, and things like logging, which is pretty great. And looking at an individual app, you see that we have an API layer here. It's just an HTTP RESTful API, and that is something that external apps and like non-F# apps can easily talk to. So an important thing that we need to deal with is the language of scientists. So we have lots of different groups. Every one of them has its own language, and sometimes there are some ambiguities in terms of terms, and so we need to address that, make sure everyone understands each other. And so the way we deal with it is through ontologies. So it's a central place where all of the terms are stored hierarchically, and here you can see the database schema for that. So at the top level you have domain, then you have namespaces within the domain, then you have your tags, and you have things to manage relationships and to assign those tags to objects. So let's look at the apps and the front-end stuff. So LIMS is hosted as one large application, and it has a set of kind of federated Fable applications inside of it. The first one we're going to look at is DNA Designer. A neat thing about it is that inside it uses a special language that scientists can work with to define their DNA. And if you want to learn more about the language itself, you can check out this article, and you can look at the Dimitrix's talk by Darren from 2017, which focuses just on this language. Pretty interesting. And so, yeah, scientists define DNA here, compile, making sure everything is good, and then they access it here and take different pieces that are available, build the resulting sequence, save it, and once they're done, they can actually build it in the real world, and then they need to make sure that it is good and it is constructed as expected. So it goes through sequencing, and here you can see the result of quality control. And these little red sections, they show deviations. Another important thing that we need to do is to keep track of everything. When, for example, you put something into a freezer, you need to know exactly where it is when you come back for it later. And so scientists at Dimitrix, before going to the freezer, they first look things up in LIMS, find the exact location of like the plate or whatever it was, and then go get it. Another important aspect, as I mentioned before, is to be able to coordinate between humans, robots, different groups, and make sure that things are handed off at the right times. And so here you can see some of the software that helps with that. Here is the schedule of submissions for analytics processing. And on the right, you can see a sort of a visualization of experiment process. So on the left here, you see what's planned. On the right, like what's actually executed, and all kinds of associated data and like structure stages of the experiment. This is an interactive way for users to set their layouts for the experiments, to define what is inside the plates and in which locations. Very nice and convenient. And this is built in Elmish with an underlying React component, and there's lots of SVG magic going on under the hood. And another thing is data visualization. So we have a lot of data coming from various robots and a lot of fermentation data specifically. And for fermentation, scientists need to track a lot of different parameters as the yeast just grows, does its thing. And this is a way to reason about this data, analyze it, compare different runs and such. And this was built using a nice open source library of Elise Plotly, which is a Fable wrapper around Plotly.js that is a port of Python's Plotly. So this is an example view of Grafana that we have set up and connected to our warehouse. And this is something that our scientists use to build their own dashboards and to just play with data as they please without really having to write code for it. And the last app is Dasware Linter. It makes the setup of reactors easier. So for some kinds of reactors, people need to write basic scripts, and this helps them with the syntax and sanity checking. There's this on hover information, and also there is some magic in the right panel that, so basically the app uses set points parsed from the script in order to predict titers using a deep learning model trained on previous fermentation runs. And yeah, now let's actually move to F# and what is its role in all of this. So if you think about what makes building software enjoyable, when you start modeling your domain and working with some data, you really want it to be just easy and natural. You don't want to think about it different from the way you think about it when you whiteboard your solution. You don't want to spend a lot of time on error hunting, and you really want to focus on solving problems and not on just kind of related boilerplated ceremonies. And you don't want to feel stupid when you do async and parallel programming. You just want it to work and to have nice primitives for it. And of course, you need good tooling that covers your needs. And a great bonus is a supportive tech community. And it becomes vital, especially for smaller companies that don't have their dedicated competency centers or experts that are willing to help if you cannot find your answers on Stack Overflow or something. So let's see how F# will help us with some of that, and is helping. Excuse me. So one thing that is really great for modeling your domain that F# provides is the type system. Things like records or end types, discriminated unions or types, a cool thing, single case unions that help you to differentiate between primitives across domains, like for you not to accidentally get a vessel by using a tag ID or something like that. And of course, good collections and functions helping to process those collections, and pipe operator. All of this combined for a C# developer might feel like a better version of LINQ. So in terms of error hunting, so previously I feel like I spent way too much time on it, but here I mainly do it if something goes wrong when I'm doing some integration work, or maybe if it's an error related to issues with some JavaScript component that I'm using, but not as much troubleshooting of our own code base. And why is that? So one thing is the compiler. Really, the compiler has become my friend. It really helps me where I forget things or miss things. Type safety is pretty great. And immutability by default helps a lot. And the good thing is that if you really need to have things mutable, you can do it for like performance reasons and such. Then another good thing is option types that helps you to avoid null reference exceptions and such, and to encapsulate your existing data in some, and if you have nothing, you just say none. Units of measure help you not to confuse, like, I don't know, liters and meters or something like that. And last but not least is the approach called relay-oriented programming. So here you see a picture that sort of shows it. So the idea is to have your bits of code to kind of exit paths, depending on whether your function succeeded or failed, and then you can connect those pieces together in the right, like, based on the flow that you're going into. And I'll show an actual code example of it next. So here you see a type of result that we have defined in our code base. So it's either a success containing some data, or it is a specific failure message. And when you use this, you actually don't even have to write any special code every time. So here, computation expressions help you. They encapsulate this. And so when you write a function like this, you basically wrap your output, which is like experiment in this case, in a result type. And that helps you control your code flow and not have any like boilerplate to write every time you want to do error handling and such. And we actually open sourced our control flow library, and so you can find it if you follow this link. So as for async and parallel programming, here again, computation expressions help a lot. It's nice and easy to do it, and also you have a lot of helper functions that can help you build hierarchies of your async computations or run them in parallel, stuff like that. And here are some links for you to learn more about that part. As for tooling, I think currently, or at least based on my experience here, it seems to be pretty much covering all of our needs when it comes to working with data, working with web, infrastructure-related things, and other stuff. And a cool thing is that we also have all of the bigger .NET World tools available to us, and also through Fable, we have a lot of the JavaScript goodness available for us too. And the F# community is just awesome. They will help you to solve your technical problems. They will help you find a job if you're looking for your first F# job. And if you want to learn F# in a structured way, you can sign up for a mentorship program and do it this way. So yeah, it's pretty awesome. So here, let's look at the front-end part of things. So it is a short example of model view update and how it works in Elmish. So here we have this little file upload component. So the model holds all the data. The view is basically all of your HTML elements represented as lists, which gives you a lot of flexibility to compose them and such. And then you have your messages, and the update function updates the model based on your messages, and your view gets re-rendered. So it's a very good approach to building UIs, and you can build complex things without too much headache using it. So if you look at the web server and API, it is pretty straightforward. So we have a thin proxy layer for the APIs to talk to them. And then here you can see what our endpoint dispatching looks like. So basically, we have authorization here, and we have like handling of the JSON parameters here. And actually, the web API the web API implementation is open source too, so you can check it out and try to use it. So data, we have two ways of working with the database. One is for when we have just static queries with parameters, and for that you just use the type provider that we built. And if you have dynamic queries that are generated based on like optional filters, it's Dapper plus our own custom query builder that is also open source, and the link is here. So is there any room for improvement? So, well, of course, we live in the real world, so there are some things that we hope that would be better. So we would be a bit happier if there was a native task support in F#, and I know there's work going on in that area, and so I'm excited to finally see it in the language. And then another thing is tooling. It is pretty great, and even though our team works across different setups and different OSs, everyone is using either Rider or VS Code, switching between them. Sometimes we do hit performance issues because our code base is pretty big for F#, and so yeah, it gets a bit rough. And of course, whenever it comes to integrations and specifically like interacting with native JavaScript, things can get rough. And yeah, then scientists who try to do scripting, they report that it's a bit harder than it should be sometimes, but over time, there is improvement, which is great. And sort of related thing, some of the people have tried using Jupyter notebooks with F# and have built some nice UOCs and such. But for people who come from Python world, some things are missing, like interactive widgets, for example. And so with that conclusion, basically Biotech is really a very tough ultimate test for a programming language and the ecosystem surrounded it. And F#, I think in our case, has passed this test successfully. And it has been a joy to work with on the back end and the front end, and it removes a lot of headaches and PTSD when you're trying to refactor. And the resulting code is maintainable and reliable, and it can be delivered quickly. This has been helping us be productive a lot. The learning curve for new people is a little bit steep, but manageable, and people get over that and make valuable contributions to our code base, and that includes interns who didn't have any prior F# experience and not much programming experience before, and also scientists who come from various backgrounds, including people who don't have any prior coding experience at all. And I think that's all. Thank you for listening to me, and I hope you enjoyed the session.
Perfect. Thank you so much. It was a great session. So I was going to say we're right on time, so we don't have any questions we can ask right now. So if you want to go to Twitter and answer those questions, that will be great.
Oh yeah, I'll be happy to answer them.
Excellent. Well, thank you, everybody. Thank you, Olia, for taking the time to present for us at .NET Conf.